So the time has come to strip this engine, see what condition it's in. There are quite a few items on this engine that I do want to change. First of all, I'm going to need an adapter plate and a flywheel to mate to the Land Rover gearbox. This front bowl sump is going to have to be swapped for a rear bowl sump. I'm going to remove the EGR valve. These engine mounts will come off. I'll have to get some custom mounts. It actually has a mechanical injection pump on it already. The original injection pump was an EDC version, but that's already been taken off by the person I bought the engine off of. It does have power assisted steering, which is great, something I don't currently have in the Land Rover, but I intend to fit a power assisted steering box to make that possible. I'm sure I'll have to do a new timing kit on this vehicle. Change the water pump. Here's the turbo. Seems as though the turbo is not in great condition, but anyway, I want to upgrade that. So I think first things first, just need to start taking this apart and see what we find. So that's the turbo and the exhaust manifold off. Now the turbo is going to be a critical part of my build. I want to try and get a bit more power out of the OM606, seeing as it has so much potential. This is the original turbo from Mercedes, and as I understand, this is good for about 170 brake horsepower. Now I think my best option is to get a hybrid turbo. That's one that utilizes this standard housing at the bottom, but I think it's cleaned up, machined out, new wheels inserted, slightly bigger compressor at the top. Now if I do that, if I use this standard, or like a hybrid version of this standard turbo, this 3-bolt mounting flange will be fine for the existing manifold. But if I decide to go for an aftermarket turbo, I think a lot of them have 4-bolt flanges, T3 or T4, which means I can't use this manifold unless I get some kind of adapter. There are adapters available online, or I get a new manifold that has the different bolt pattern for those aftermarket turbos. My goal is, I think, something in the region of 300 brake horsepower, and as far as I understand, that's a relative straightforward to get if I get a hybrid version of this standard turbo. This one seems to have a lot of play in the shaft here, so I think it's no good. Even if I were to use it, it would have to be rebuilt. You can see some other elements here. This is the oil feed for the turbo, and then underneath you can see the oil drain, which is a pipe back to the sump. You can also see the waste gate in here if I turn it around. So there's a little flap inside there that opens. So I'm not quite sure how it was operated in the original car, maybe electronically somehow, I don't know. But I know my setup, this is going to have to be a whole mechanical setup. So I think normally you have a pressure pipe that comes from the cold side of the turbo that feeds into an actuator, which then operates this arm when the cold side reaches a certain pressure, such as 1.5 bar. Then this arm will open, allow exhaust gases to escape through here, and preventing the turbo from over boosting. So I'm still doing my research on what's the best turbo to get and manifold setup. If I keep the standard turbo, then I can use this. I managed to get this from the original car. This is the exhaust part of the turbo. So this joins up here with this clamp to hold it together. So if I fabricate my own exhaust, I can build something off here. So that's the plan, although I haven't quite decided exactly which way to go just yet. So this is the mechanical injection pump. So this pump didn't come with my engine originally. My engine had an EDC pump, an electronically controlled injection pump. This particular mechanical pump came off the previous generation engine that was normally aspirated. But it's a straight fit to my engine, and it's the key to making the OM606 a very special engine. You can get the high power figures from the turbo motor, but you can keep it completely mechanical, which is what I'm after to put into my Land Rover. Now in its standard form, this injection pump I think is capable of making something like 70 brake horsepower. So I'm gonna need to rebuild it to provide more fuel to the engine to increase the power. So this pump has 5.5mm Bosch elements in it. I have a number of options there. They need to be upgraded. The easiest option is to take the 6mm elements out of the EDC pump, swap them into this one, which, as I understand, can give me the potential with the right turbo of getting close to 300 brake horsepower. There are also aftermarket elements that go right up to 8.5mm that would enable me to get much more power. I'm looking at a particular set of elements from Diesel Pump UK, 7.7mm elements, which would definitely get me over the 300 horsepower figure that I'm hoping for. But I understand they're not ideally suited to using a manual gearbox, which is what I have in the Land Rover, as it causes jerking to happen. So I just need to do a bit more research into that to decide exactly which elements to get for this injection pump. Just a few other interesting things to note. So this here is the mechanical fuel lift pump, which, although being so tiny, can provide enough fuel to get up to somewhere in the region of 500 brake horsepower. So I can keep this, which is great. This up here is the vacuum stop. So in order to stop the engine running, you have to apply a vacuum to this point, which will shut the pump down, which will turn the engine off. So I'm going to need to buy an extra unit, some kind of vacuum stop solenoid, also available from Diesel Pump UK. So I can install it in my car, so as I turn the key off, then it will stop the engine running. This injection pump was not designed for a motor with a turbo. So We also need something extra to tell the pump to provide more fuel as boost increases. So there's something called an alder that you can buy to fit to this pump. It's fitted in this area here and will operate this lever to provide more fuel. So it will have a pressure line coming from the inlet manifold, which is connected to an actuator, and then a lever or an arm that will operate here. So as the boost increases, it will operate this lever here, ensuring that more fuel is provided to the engine. So I'm looking forward to rebuilding this injection pump. I'm still doing a bit of research to find out my best options, but with that goal of trying to get somewhere in the region of 300 brake horsepower. So this is the sump removed, but this sump has a front bowl which won't work in my vehicle due to the solid front axle, so I'm going to need to swap this sump. So apparently a Mercedes OM606, another 6-cylinder engine, has a rear sump that fits on my motor, so I'm going to take this away and see if I can swap it for one of those. It needs the oil pump to suit the sump, so that's going to have to go too, and the dipstick. So hopefully I can manage to get the correct sump with the oil pump and the dipstick so I can fit it on my engine. So everything's going well so far. The engine seems to be in reasonably good condition. I don't see any excessive wear on the camshaft lobes here, which is good. A couple of small issues I need to deal with. This is the oil feed pipe for the turbo. I'm not able to get this fitting out here. It seems to be seized into the block, so I need to make a plan there. The auxiliary belt tensioner bracket. This one needs quite a large Allen key to undo that, which I don't have. I need to get hold of one so we can get that bracket off. There's a pin in here that I think is threaded that I can put a bolt into, but I need a slide hammer in order to get this pin out, which will allow this I think chain tensioner to come out, which I'll need to do to get the head off. And also these cam support brackets here have a 9mm 12-point head, which I don't have a socket for that, so that's another item that I need to get before we can move on to the next stage. So that's it for this video. The next video we'll hopefully get the head off so we can check out its condition, have a look at the pistons. Hopefully we can also get the caps off the crankshaft so we can see what condition the bearings are in, maybe even get the whole crankshaft out so we can see where we stand, and then we can see what we need to do to put this engine back together. Thanks very much for watching. Please give me a like and subscribe if you enjoyed the video, and we'll see you on the next one.